Hey everybody, Darren here with Renaissance Coders. Thanks for joining us for another Unity scripting tutorial. We're going to be adding fade transitions to our scene manager today. So let's go ahead, jump into the code, and see what that's going to look like. Okay, so this is the code that we're starting off with. I created this in a previous tutorial. I'll go ahead and leave a link to that if you haven't checked that out. So I'm not going to be covering what we have here already. The first thing we want to start off with is defining a few variables. Okay, so first off, we want to have a transition smooth time, which is going to dictate the real time in seconds, how fast we will fade to black or fade to fully transparent. Then we're going to have a member variable that refers us to our target scene. So anytime we call our own load scene, we're going to create our own load scene method. Anytime we call that, we're going to be setting target scene. Then we have a reference to a canvas group. Now, if you don't know anything about Unity's UI, don't worry about it. We'll cover this part in a little bit later in this tutorial. Basically, this is going to be what controls the alpha of all of our elements on our canvas. So all of the UI elements have an alpha channel, or all elements that do have an alpha channel will be manipulated by the canvas group alpha. So all we have to set is that component. Okay, after that, we want to go ahead and add a method called transition to scene. And this is going to essentially accommodate the same functionality that SceneManager.LoadScene does. It's going to be a function that ends up calling SceneManager.LoadScene. Okay, the first thing you want to do in this method is check to see if our active scene is equal to the string that was passed. In other words, we don't want to try to load a scene that is already active. Next, we want to go ahead and set the target scene variable that we declared up top. Okay, and now we're going to start getting into the functionality that actually causes the or affects the transition, the canvas group alpha. And the way we're going to accomplish this is through a couple coroutines. So if you don't know what coroutines are, we're going to get a crash course on them right now. So I'm going to go ahead and start off by saying IEnumerator transition with alpha. And you can treat this like a method. So it's going to take a parameter, and that parameter for now is going to be target alpha. Now I'll say you might run into a compiler error if you write this code and you don't have this using statement, using system.collections. That is a default using statement, but in case you happen to delete that, you may get an error. So just make sure you have that using statement. So I'm going to start off this coroutine by defining a couple helper variables. Okay, so we have a float called diff, which is going to keep track of the difference between our canvas group alpha and the alpha that we're passing via target alpha. So let's go ahead and add the function call for this coroutine, and it's going to look like this. We'll say start coroutine, and we're going to pass the string value, the name as a string to this function. So we're going to be passing as a string transition with alpha, which is the name of that function. Now that takes a parameter, so we can add that parameter by placing a comma and then passing 1, because we want an alpha of 1 means that our canvas is fully opaque, meaning the black image will be fully visible. Now anytime we call start coroutine on a method that could be called at any point in time, we want to make sure that we're stopping that coroutine first. Now the reason we want to do this is because it's conceivable that while we are transitioning to a scene and we're mid-alpha, so if our alpha is 0.5 and we call transition to scene again, that we're going to conceivably start another coroutine. And we want to make sure that we're stopping this before we do that. And to really understand why that's necessary, you need to understand what a coroutine actually is. And on the high level view of a coroutine, it's really just a process. That's how you can think of it. Think about it as a different update function. So it will be updated as void update is, but it won't be called at the same time as update. So in other words, we could call start coroutine, we could call this 5 times. So if we call this multiple times like this, then we would essentially be spawning 3 processes that are running the code within this coroutine. So don't think that that's just going to only be calling that code once, regardless of how many times we call this function. So we want to make sure that we're stopping that coroutine before we start it. Okay, so we have these initial variables. Now to get into the core of the coroutine, and something that you'll see many times in coroutines is the while loop. And our while loop is going to run on the condition that the difference between the current canvas group alpha and the target alpha that was passed into this function, the difference between those two values should be greater than 0.025f. Now, this can really be anything that you want it to be. This can be, 0.001. It should be a value greater than 0, so that we can make sure that we're getting out of this while loop in a timely manner. So 0.025 is a good value. And again, that means that this while loop is going to be running while the difference between those two values, these two values right here, is greater than 0.025. So with that being said, we want to make sure that we're calling this, we're basically updating the difference in this while loop. Now, why am I going through all this trouble to create a coroutine? Why don't I just put this code in update? If you put a while loop in update, it's going to freeze the program, bottom line. You'll see a short skip in the program, because basically all scripts are going to share the update function. If you have one script running a while loop, none of the other scripts update calls are going to be called. So we create a coroutine because that is a separate process. Okay, to continue with this, we want to be modifying the canvas group alpha. So go ahead and write the following line. Okay, so this is a pretty important function call. I'll go ahead and dissect it. If you're familiar with mathf.lerp or vector3.lerp, this function is pretty similar. SmoothDamp is a similar function, and it's really just a matter of preference. I find that SmoothDamp is a little bit better, a little bit smoother, if you will. And here's how it works. We're going to pass in the current value that we're trying to modify. Notice that we're setting this value equal to we're setting the function of this value equal to this value. So it's the same value. Basically, we need to pass the current alpha. The second parameter is the target alpha. This ref transition rate. So transition rate is a variable that SmoothDamp is going to use, because the way SmoothDamp works, it modifies the alpha. It modifies whatever value is passed here at different rates over the course of its execution. So that might be a little bit complicated, but that's how the function works internally. So we don't actually, I define it up here, that's a requirement, but we don't actually need to do anything else with transition rate. The reason it's ref is because that's allowing us, the function gives you the opportunity to know what the transition rate is at any given time. So if I wanted to do something else with transition rate, if I wanted to know how fast my alpha was being updated at that current frame, then I could do that. Now transition smooth time is the value that we created up here, 0.1, which means that the canvas group.alpha is going to reach the target alpha in 0.1 seconds. The last thing we want to do in this while loop is yield return new, wait for seconds. And this is a requirement for coroutines. I'll talk about some alternatives, we're going to be passing time.delta time into this. Now, the reason I like to do this with coroutines is because it's sort of mimicking the refresh rate of update. Update executes at a time of time.delta time. So we're going to just sort of try to mock that as best as we can. Some alternatives, we could, instead of writing yield return new wait for seconds, we could say real yield return null, and that's basically going to update this coroutine instantaneously over time. So it's not going to wait at all. Okay, and that's all we need for this while loop. Now, when the coroutine exits the while loop, what we want to do is make sure that we force the alpha to our target alpha. Now, why do we do this? We are executing this while the difference between those two values is greater than this, which means when we come out of this while loop, our canvas group.alpha is not going to be exactly our target alpha. So we want to make sure that we are forcing that value on canvas group. Secondly, we want to check, well, actually, we'll get to that in just a moment. You might notice that we're not actually calling SceneManager.LoadScene anywhere, and what we're going to do is create another coroutine called LoadScene. And this is our local LoadScene function. Okay. Now the goal of this coroutine is to actually load the scene, as we can see by the name. Naming conventions are good. Okay, now at the bottom of this coroutine, the first one that we created, we want to say if target alpha is equal to 1. Now, what does this mean? If our target alpha is 1, that means that we're trying to go to a scene, which means that this is the point where we want to call load scene. Now, we're going to call start coroutine, load scene. And I'm not going to call stop coroutine on this because calling stop coroutine on the initial coroutine, when we say stop coroutine transition with alpha, sort of safeguards us from any coroutines that we're starting within that coroutine. Okay. So if target alpha is equal to 1, that means that we want to load a scene, which means right whenever our canvas group alpha is fully opaque, that's when we want to change scenes. We don't want to change scenes halfway through our alpha being opaque. So if the opaqueness is 0.5, then we'll still be able to see through to the current scene. We don't want to see any loading until the graphics of our game are completely hidden. Okay. Now, what's the purpose of running this coroutine? Why not just call SceneManager.LoadScene? And we're going to see why in just a second. So in this coroutine, we want to declare the following members. Okay, so what do we have here? We are actually calling SceneManager.LoadScene. So this is the point where we are mocking the function or duplicating the function that we called originally in the first SceneManager tutorial. So we're actually calling LoadScene here. So why do we need to continue with this coroutine? Well, the thing is, when we call LoadScene, we aren't instantaneously switching to that scene, especially if we have a lot to load in that scene. There could be a load time associated with it. So what we want to say is, okay, we're loading the scene, and now we're keeping track of the active scene. And the reason we're doing that is because we want to say while the active scene is not equal to our target scene, which essentially just means while we haven't loaded this scene yet, we just want to update the active scene. Okay. And I should point this out. When we call it this coroutine, when we say start coroutine, everything is only going to be called once. Now, the reason that we are able to update code over time is because we're using a while loop. So when we call start coroutine, this gets called once. This gets called while this condition is true, which is, of course, what you would expect due to the nature of loops. Okay, so we're updating the active scene so that we know when to get out of that while loop. And then we're going to yield return null just like we did up here. So I'll just copy and paste that. Okay, now once we get out of this while loop, we know that the active scene is our target scene. And then what we want to do is start the coroutine to transition back to full transparency. So we're transitioning to the alpha of 0, which should shed some light on why we're checking if our target alpha is 1 here. Because when we call 0, when we call this coroutine with 0, we don't want to load any scene. So we don't want to start this coroutine if we are changing the alpha to 0. Okay, now there are a couple of lines of code that we missed. We need to make sure that we're adding a canvas group, or we're defining the canvas group. So the canvas group is going to be equal to get component canvas group, which implies that the object our scene controller is going on will have a canvas group. So we'll talk about that more a little bit later. And then, of course, we want to be calling the function that we created in the first place. So we're going to be replacing these two lines with our local function. So we want to be calling, instead of SceneManager.LoadScene, scene 1, we want to be calling transition to scene, and then pass that scene 1 value. And the same thing with scene 2 if we press B. Okay, and that's all there is to the code. Let's go back to Unity and see what else needs to be done. Okay, so no errors, which is great. We want to go ahead and add a canvas because, as I said before, our scriptable object, or I'm sorry, our scene controller is expecting us to have a canvas group, which needs to go on a canvas. Now, in this canvas, we are going to have an image, which is going to serve as our loading screen. And we want to make sure that this image is always going to maintain the width and height, the aspect of our screen. So we're going to drag the anchors out to the edge of the screen like that. I'm going to set this image to be black, and then I want to add a text component, which gives the user some feedback on what's going on when this loading screen comes up. All right, and that's all we need to do there. Now our canvas is going to be our scene controller. And what we're going to do is add the scene controller component. You can see we have a transition smooth time here, which is going to give us easy tweaking on how fast we want this to actually fade in and out. And last but not least, we want to make sure that we're adding the canvas group. So our script modifies the canvas group.alpha. We'll see what that does right here. So we get a nice transition just by modifying that one value. Canvas group.alpha will modify all of the children of a canvas group which have a alpha component. In other words, the image here under the canvas has a color which has an alpha, and the text also has a color which also has an alpha component associated with it. Okay, I'm going to start off the canvas group at 0 and then run the game. And now we can switch scenes, and you can see nicely that we go from scene to scene. Now, is it conceivable, let's go back to the script. Is it conceivable that we could just call SceneManager.LoadScene right here? Yes, it is. It is completely possible, and with the two scenes that we have now, which have almost nothing in it, you wouldn't even notice the downside to doing that. However, if you have a large scene where you're loading a lot of materials, a lot of objects, then you will notice an issue where you see the scene loading, or you'll see the loading screen fading out before the scene is actually loaded. So to give you some validation on that actually happening, we are going to test to see whether this while loop is ever being activated, because if this while loop isn't being activated, then it would be useless, because it would mean that our active scene is our target scene instantaneously after we call this. So on a simple scene such as what we have, the two scenes that we have now, if we see this debug log getting printed, then that gives us an indication that the second coroutine is absolutely necessary. Okay, so there's our debug log for loading. Let's go back to Unity and see if that's actually getting called. Okay, so I'm going from this scene to scene. Let's check our log, and you can see that it might be actually getting called twice. Let's go ahead and make sure. Okay, so yeah, for one transition, we're loading it twice, and all we're loading is one object. So try this out on your own scenes, and you'll see that this loading debug log is actually getting called probably way more than what's actually happening here. That's going to be it for this tutorial. Hope you guys learned a lot about coroutines and scene transitioning. If you did, go ahead and drop a like. Go ahead and share this video for us. It really helps us out, guys. But anyway, thanks for watching, and have a great day.